Hi, in this lesson we're going to go on and continue looking at functions. In order for a function, a relationship of numbers to be a function, each member of the input, which is our domains or the inputs, so that's kind of a new term there, I'm going to underline that, need to map to only one member of the range or the outputs. Because we do so much of our work with the XY coordinate system, I think we get used to thinking of the inputs as the X values, but I want you to recognize that it wouldn't necessarily have to be X. And the same thing with the range, we get used to looking at those outputs as the Y values. It's your outcomes. In fact, in the last lesson, we just kind of looked at new notation where we were looking at naming our equations. You know, A of X is equal to some equation. In fact, I know in a previous lesson we had looked at the situation for cost equation for renting a bike. I think it was, we said C of H was equal to $5 per hour for every hour that we rented plus a base rate of 15. So that was an example of a linear function. And in that one, I labeled my input as H and my output as C of H, or C. Okay, so that kind of gives us a little bit more depth to what we're talking about here. But we're looking at, in order for the relationship to be a function, the relationship between two sets of numbers, every X value or input can map to only one value in the range. So in other words, there's no repeat or repeats in the domain or the X values. Okay, so we're going to look at 6 different situations here, sets of numbers. In other words, we're not looking at the graphs on these. We're just going to look at the numbers in point notation, or perhaps the sets of numbers are given to us in charts. So we're going to identify the domain and the range. Now remember, the domain is a set of inputs or X values, because we're talking about points on an XY coordinate system eventually. So our X, or our domain, or X values, we can write that as X such that X, and very often that line can be written like that or with a colon. I'm not going to be so big on the notation here, but the way that you read that X value is such that X is equal to 1, 2, 3, 4, 5. So all I did there was I listed my X values, and there are no repeats in those, so we're all good. Our range are all of our Y values. So you can just list them as 5, 7, 9, 11, and 13. Again, you don't have to get fancy with this notation, but you might see that, and I don't want you to be thrown by that. Going down here, I'm looking at my domain, and I would list 2, 5, 2, but I stop right there because there's a repeat. So right out of the gate, we know this is not a function because there's a repeat in our input. Okay, looking at this one up here, and the information is given to us a little bit differently. It's in a horizontal chart, but here's our series of X values, and it's really easy to see that there are no repeats, and I can list those 3, 6, 9, 12, 15, and our Y values, or our outcomes, are our range, and those are 2, 3, 4, 5, and 6. Down here, we've got -8, -4, 1, -4, -8, and it's like, wait a minute, we've got a repeat there and a repeat there. So this is not a function. These others where we've listed domain and range, they were functions. That's why we were able to go ahead and list the domain and the range. Okay, so here, again, we've got a chart, but our information is given to us vertically. But we can see our X values very easily are 1, 5, 9, 13. There's no repeats. The Y values are 7, 4, 1, and -2. This next one, our X values, we've got -2, 0, 2, 3. No repeats there. And our Y values, we have 4, 0, 4, and 9. And Y values can repeat. There can be a repeat in the outcomes. A lot of times students are like, well, why is that? And I think the easiest way that I can give this to you is if your employer has a formula for calculating your pay. For most of us, our pay is calculated by the number of hours we work. If you worked 13 hours this week, you should be able to calculate and know exactly what your pay is going to be. You'll know your outcome. There's only one outcome when there's the input of 13 hours. It isn't a case of there could be a variety of outcomes for working 13 hours, unless you have a different pay rate, and that would be a different pay function. So that's the easiest answer that I can give you right now. So now when we're looking at kind of doing the same thing here, we're going to be looking at identifying our domain and range, but now we're looking at some different scenarios. Up until now, we've only been looking at linear equations and linear functions where it's a straight line. These others have curves, and so it's going to be a little more challenging to identify our domain and range, and first of all, to identify if it's a function. Remember, a function, every x value is used just once. And so we can kind of develop this vertical line test. If I look at my pencil as a vertical line going across this graph here, we can see that pencil intersects twice here and here, no matter where I put the pencil along the x-axis. So in other words, when x is equal to, -6 here, it intersects here and here. When x is equal to 0, x intersects here and here. The line x equal to 0, this vertical line intersects twice. So this would not be a function. So this is not a function because it did not pass what we call the vertical line test. I'm going to turn my paper sideways and write that. I would encourage you to do the same thing. What I'm doing here is encouraging you to use the vertical line test to see if a vertical line intersects it twice, more than once, it's not a function. And this one here, when I do a vertical line through here, it's going to intersect it only one time. It looks like it gets close here, but it turns on itself and moves away, that there's really only one intersection here. So I don't know what happened to my D here, but I'm going to talk about the domain. The domain, there's all x values eventually are used here. As I'm moving horizontally here, every x value gets used. I mean, this arrow means that it goes on, in this case, to negative infinity, and below here, it goes on to positive infinity. Every x value is going to be used. And so we can kind of identify that as all real numbers. Every number out there can be used in that domain. And then the same thing, if we actually looked at this, imagine that this, as it's turning, would curve, and basically all real numbers eventually would be used in the y values as well. I'm going to show you another way that we can communicate that, but for right now, all real numbers is going to work for our domain and range in this one. This is a segment from a line, just a line segment here, and it looks like it goes from 2 to, let me see, 9 horizontally. So our x values, and I don't know what happened to my D here for domain, but my x values would be anywhere between x is greater than or equal to 2, but less than or equal to 9. And this set notation is kind of, actually it's not set notation, but it's this notation shouldn't throw you, that you're saying x is greater than 2, but less than 9. It's called interval notation, but it shouldn't throw you because we've had this before when we were dealing with inequalities where we were at least dealing with that much. Okay, so for our range, looks like our range, our y values are going anywhere from 1 up to, it looks like 6. So our y values are going to be greater than or equal to 1, but less than or equal to 6. So that would be interval notation. I guess I could write that for you if you wanted to look up that again. Interval notation is what I'm showing you here. Okay, and this one's a very unique one, and it's definitely got a curve going on. Our domain, considering that this would probably go on and on forever and on forever, it looks like all x values eventually would be used, way out into infinity. I'm going to go with all real numbers here based on the arrows there. And then our range, it's never going to be negative. Our lowest number on the range is 0 here. It doesn't go into the negative zone. So basically we're saying that I'm going to write it out as an expression here. All positive numbers, or real numbers, are going to be part of our range. Okay. Now I want to point out that the first one was not a function. because it didn't pass the vertical line test. But these other three, the second one where sideways S here and where we have this U, we haven't had those before. And I want to point out that if I would show you the equation, like this one here, the equation would probably be y is equal to, or I could write f of x, 4y, is equal to, I think it'd probably be x minus 4 squared. You'd know that there'd be a square here. And I have a half a feeling this one would probably be f of x. A lot of times we do f for our y, would be equal to probably cube root of x. It's probably, and you notice that we've got an exponential here. So what I want to point out is anytime you have an exponent or any kind of an exponential expression as part of your equation, you're going to get a curve. So I want you to recognize that any of these equations that you have with any kind of an exponent, you know it's not going to be a straight line. A straight line is going to have x and y, but no variable is going to be raised to any power or cube rooted or square rooted or anything like that. So that's just kind of an eye-opener there. Okay, going on to our last activity on this page is we want to take a look at what we call a piecewise function. And this piecewise function is looking at several different sections that come together on one graph. And we're going to take a look at describing the domain. Now, when I look at the domain, I'm looking at all the x values. So I'm looking right and left here horizontally. Are there any x values that would not be used to plot a point on this? And being this goes on and on to the right and on to the left, sure looks to me like we have all real numbers again for our domain. And you can identify that in set notation, which I started to do before, but I kind of decided to do one thing at a time. And I'm doing the sideways 8. And that's saying negative infinity to positive infinity is another way to identify all real numbers. So again, just some new notation. Describing the range, when I'm looking up and down, what y values are used. Looking over here, it looks like my y's are staying pretty much between 2 and negative 1. But when I go over here, this is going to go on and on and on forever. Every y value in the positive zone is definitely going to be used. So my lowest value for y would be negative 1. And so we identify that describing my range, my y values would be greater than or equal to negative 1. Okay, and so the next question I'm asking, what part of my picture there, or for what values of x, is the range increasing? The range is my outcome. Do you see how the range is increasing here? So it looks like, if I'm looking at the letters here, it looks like, you know, between C to D, they are increasing. But maybe your graph isn't going to have lines like that on it. Maybe it's asking you to identify for what values of x. So you would say something like, for values x, all x values that are greater than or equal to, it looks about right here at 2, that's where we hit the lowest point at x equal to 2, and after that it starts to increase. So for x values greater than 2, y would be increasing. So the next question, where are the values of the range decreasing? In other words, for what values of x is d, as I progress from right to left, or left to right, I'm sorry, where x is increasing, where is y decreasing? And that would be between b and c. So I'm going to write b to c. But if I was going to write that interval, I would write the interval as x, all those values of x that are greater than or equal to at negative 2, it starts to decrease. And then it ends at positive 2. So between negative 2 and 2, for x values between negative 2 and 2, it looks like the y values are decreasing. Okay, so the last thing that we need to take a look at are at what intervals in the domain are the values of the range constant. So when I look here, it looks like right through here, my outcomes, my y is always going to be 2 between a and b. So between a to b, it's going to be constant. And if I would write that in set notation or interval notation, it would be x, all those x values where x is less than 2. And I could put the equal, but I'm just going to, because I've already included 2 in that particular phrase, I'm not going to include it here. Just a closer look at interval notation, set notation, and just the whole concepts of domain, range, functions, and what they look like graphically.